Okay, Year 12s, we are doing 16C. You really probably need your booklet in front of you so you can fill it out, and your calculator, because a lot of this is you need to get results from your calculator. So, all right, currently we can only find probability of intervals which are whole standard deviations from the mean. That's how much we've done so far. To find the probability of intervals with limits other than whole standard deviations, so ones that are not 1 or 2 or 3 away from the mean, we're going to use our CAS. And these are the directions. We're going to go menu, probability, distribution, and number 2, normal CDF. Now, I won't be showing you on this video how to use it because I'm sure you have all done it heaps at the moment. All right, so let's have a look at the first one. Find the probabilities of the following normal distributions. All right, so we have an x has a mean of 100 and a standard deviation of 15. So if we were going to draw that curve, should have given myself more room, that's all right. Right down the middle, hopefully you're doing it by 2, is 100. Now, if our standard deviation is 15, that means 1 up is going to be 115. 2 up is going to be 130. And 3 up, because I'm adding a 15 every time, is 145. Okay, and going down the other way, we have 85, because I'm taking off 15. 2 standard deviations will be 70, and then 3 standard deviations will be 55. My line would be like this now. That's okay. All right. So this is stuff we should know by now, hopefully. And now this question is saying, what's the probability that x is greater than or equal to 76? And you will see in here, damn it, the 76 is going to lie in between. It's not a nice 1 standard deviation or 2 standard deviations. So we can't do the normal 50% plus whatever this is. So this is when you need your calculator. So these questions are more than likely not going to be in the non-calculator section. They'll be in the calculator section. If they're in non-calculator, it'll be an educated guess that you are going to make. All right, so what do we do? So we use what we've done up the top with the calculator. We're in normal CDF. Hopefully you're in that now with your calculators. Greater than or equal to 76. So you need the first 2 here that you set are the boundaries. So it's going to mean all this space above 76. So your lower boundary is going to be 76 and your upper boundary is going to be infinity. And then you need to put the mean, which in this case is 100. Oops, no bracket. And the last one is the standard deviation, which is 15. Nice and simple. Hopefully you get 0.945. All right, so second to that, if a normal distribution is standardized, what is the letter assigned to represent the number of standard deviations? Hopefully you're all yelling at the screen going, it is Z. We've had a look at that. And what is the mean and standard deviation of such a distribution? So we're talking about when we standardize everything. So that means we pull into place your marks in year 12 as compared to the people in your class. Okay, great question was 16B question 13 about the two subjects that the person did. Can't remember, it was like they got 76 for one of them and they got 78 for the other. So they would say, oh, I did much better in my second subject because I got 78. But when they standardized it, they found that they actually did better than everybody else in the first subject, even though they got less grade or less percentage than they did in their second subject. So have a look back at 16B question 13 and that will make more sense. Okay, so if it is standardized, this is nice and simple. The mean is always 0 and the standard deviation is always 1. Okay, and that's how that will come about. You'll see some questions like that. All right, what if we have set for a boundary between negative 1.3 and 1.5 where Z, so we have Z here, okay? So our Z, we're talking about the standardized. So mean is 0, standard deviation is 1. And we're trying to find what's the probability that it lies between, that the results will lie between negative 1.3 and 1.5 standard deviations from the mean. That's what that question is actually asking. And so we just use the above formula again in our calculator, normal CDF. This time our lower boundary is minus 1.3, upper boundary is 1.5. Is it? Yes, it is. The mean is 0 and the standard deviation is 1. And your answer for this one you should get is 0.836. It's probably a good time to press pause and check that, okay, before you go on. All right, percentiles of normal distribution can be determined using a similar method, which is shown below. So this time we have menu probability, this distribution, but number 3, inverse. Now, why is it inverse? This time it is inverse because for this example, X is normally distributed with mean of 20, standard deviation of 4. This time, have a look at the difference. You've given the answer, okay? But you don't know what this is. It's not said what is the probability of X is less than or equal to 23, for instance. And that would be the question up here. Plug it all in and get the answer. This time you've got the answer and you need to know what that value is, okay? So let's draw a diagram of that information. Go ahead and do it without looking would be good, and then look up and see if you agree. All right, so what I've done, I've got the mean of 20, gone up by 4s, 3 standard deviations, and down by 4s for 3 standard deviations. Draw a diagram to show this scenario. So you don't know any answers yet. You don't know what A is. You don't know what this value is here, okay? So we're going to just say, where is it less than or equal to 0.85? We know that here is 1 standard deviation. So that means we've got the point of how much is below here. And then somewhere in between the middle of this, here is going to be 85%, okay, from what we know about what the curve should look like. Should be 85%. Now, if you're not sure why I put it there, okay, I'm not going to explain that now. I would love you to go back and have a look at what percentage should be in here. So that upper bit, what percentage should be in here. And then it could be obvious to you, hopefully, why I got the 85%. Or remember 0.85 as a probability. So this is if the question says find percentage. This is really important. And this is if the question says find probability. So you don't want to put the wrong answer. That could be a good multiple choice question. They could both be in the answer. So just check, does it say find the percentage? Then you'd give them this. Or find the probability and you'd give them this. And this one says that the probability is 0.85. Okay. All right, find the value of A. So this is in your calculator. So we're going to go backwards and we're going to use inverse this time. Okay, so that's... I don't need to write it out, it's here. Menu, probability, distribution, and this time it's 3 because you're using the inverse button because you have the answer and you want to find the X. So what do we put in there? This time you put the answer first. That's what it wants. And then you put the mean, which is 20, and you put the standard deviation, which is 4. Something that is really, really important, more important than what the answer is right this second for you, is that they always put the area as a less than. So it's always less than. Now what that means is if you get a question that asks for greater than that, you can find it out, but then you need to use the rest of the percentage or the rest of the area. So if you've got your 0.85 here, okay, you wanted oh no, that's not right. If you need to get, if it gives you value of this in here, but you want underneath, you need to change it to 0.85. So it may have said to you that the probability greater than or equal to a number is 15%. That's the opposite of this. So I'll say it again. X is greater than or equal to A equals 0.15. It's saying the same thing. But you've got to say, I can't put 0.15 into the calculator because that's greater than. The calculator wants to know what is below. So if you know that greater than is 15%, you have to say, what does that mean is less than? So in this case, it is 0.85. Okay, so always less than or equal to in the calculator. Ask your teacher when you come up to one of those if you're not sure what it means. In this case, I'm hoping you have spat out an answer of this. Okay, interpret this answer. So what does it mean? So we're talking about a random selection. So a random selection in 85 is 85% likely of a result of 24.1475 or less. Okay, and if you look at my graph, it's not so great, but it is somewhere between, it's just above 24. That's what, this doesn't matter too much. As long as you don't get an answer that says 16, because then you go, hang on a minute, there's something wrong with that. All right, let's have a look at how else you can get these questions given to you. X is normally distributed with a mean of 100 and a standard deviation of 15. Find C1 and C2 to make it equal to 0.5. So what does this actually mean? Let's write this here. This means the probability of obtaining a result between C1 and C2 is 0.8. That's what this means. Okay, the probability of obtaining a result of between C1 and C2 is 0.8. But we don't know what C1 and C2 is, so that's what we have to do first. So let's draw a diagram because it says to draw a diagram. You're going to get so good at these. All right, so down the middle we have the mean, which is 100. Yuck. Up here, we're going to write C2 because we don't know what that is yet. And down here, we're going to write C1. And it is saying probability of getting in between all of that. And it's a probability, so it's a decimal, is 0.8. All right, so now the next question. For the sake of symmetry, what's the probability of getting less than C1? So let's draw that again quickly. Oh, my Lord, look where my mean is. Please excuse that line. This is 100, and this is C1. Okay, so let's have a look at what the question is. For the sake of symmetry, meaning this side is identical to this, what is the probability of being less than C1? You could go, well, I don't know, because I don't know what C1 is. Have a look back here. If all of the middle is 0.8, what is left? Remembering that all the area under the curve is going to equal 1. So you have 0.2 left. So that means this must be 0.1 because it is symmetrical, and this must be 0.1. Okay, so your answer is this must be 0.1. All right, and let's do the other lot, the other side. They're going to ask us the other side now. And don't put your mean in first, Vicky. That's the way to go. So we've got 100 and C2. What is the probability of being less than C2? So that's going to be 0.8 plus 0.1. 0.8 plus 0.1. So your answer is 0.9. Or it's the opposite of what you got up here. If this is 0.1, then this part's 0.1. So anything below that, which is this diagram, is going to be 0.9. All right, find C1 and C2. This is straight into your calculator. So inverse norm. Let's do C1 first. So we're going to have 0.1, because that's what we just found. What's the probability of the area under? Because it has to be under, which is what I was explaining up here. So it's 0.1 with a mean of 100 and a standard deviation of 15. And you should get 80.78. And then we're going to do C2, inverse norm. Now, this is up here, remember? We want all of this. What is all of this? That's right, we did it here. It needs to be under, so to the left of the line when we put in the calculator. So that is 0.9. So this time we're going to put 0.9, 115, and hopefully you get 119.22. Now, if we have a look at the graph from, any of them really, 80 and 120. So they're saying this is 80-ish and this is 120-ish. So 80-ish is about 20 under, 120-ish is about 20 over. So if you're getting 52 here and 99 there, you've done something wrong, because 100 is in the middle and they're not equidistant to the side. Awesome. Okay, they're the questions you need to do for 16C.